Okay, so let's dive into this technology we hear about constantly, large language models. I mean, what's really going on when they write a story or a poem or answer some super complex question? Well, the truth is actually a lot simpler and honestly, a lot weirder than you might think.
Now, take a look at this. A really profound-sounding sentence, right? But here's the kicker. This wasn't written by some philosopher deep in thought. Nope, it was generated by an AI in less than a second. And yet, it sounds thoughtful, almost conscious.
So you have to ask yourself, how is that even possible? Are we actually watching a machine think? Is there a spark of real intelligence there? A ghost in the machine? Or is something else going on entirely?
To really get the answer, we've got to peel back the curtain a little bit and look at the surprisingly simple idea at its core. See, it's not really about thinking at all. It's about predicting.
So here's the absolute crucial point. An LLM isn't a thinking machine in the way you and I are. At its heart, it's a powerful statistical tool. Its entire job is built on one simple principle: calculating which word is most likely to come next. That's it.
Probably the best way to wrap your head around this is to think of the autocomplete on your phone when you're texting. You know how it suggests the next word? An LLM is just that, but supercharged on a scale that is just mind-boggling. It's playing this hyper-advanced game of finish the sentence.
So how does that actually build a sentence? Well, it's a step-by-step process. Let's say you give it the phrase, "the cat sat on the..." The model just runs the numbers. Based on all the text it's ever seen, it calculates that Matt has the highest probability of being the next word, so it picks it. Then it just does it again. The new phrase is, "the cat sat on the mat," and it calculates the next word, and the next, and so on.
But for that prediction to be so ridiculously good, to go from "the cat sat on the mat" all the way to that philosophical quote we saw, the machine needs to learn from an almost unimaginable amount of information. It needs a library of, well, all of our words.
And the scale here is just staggering. We're talking about models trained on over 1 trillion words. That's not a few books. That's a massive chunk of everything humanity has ever bothered to write down and put on the internet. It just soaks up all the patterns, the structures, and the statistical connections in our language. So, where's all this data coming from? Well, you can see it's pretty much the same places we learn from. The internet, digital libraries filled with books, millions of lines of computer code, scientific articles, you name it. It's literally learning from our collective voice.
Now, this is a really key distinction to make. The model doesn't know what a cat is. It has no idea about fur or purring or that they love to knock things off shelves. It only knows that the word cat has a very, very high statistical chance of showing up near words like purr, meow, kitten, and of course, Matt.
Okay, so at this point you're probably thinking, wait a minute, if it's just a fancy autocomplete, basically a statistical parrot, how on earth does it explain physics or write beautiful poetry? And yeah, that is the billion-dollar question, isn't it?
And this is where we get to this central paradox of it all. On one side, you have this incredibly simple rule, just predict the next word. But on the other side, the results are, well, they're shockingly complex. This is what happens when you apply that one simple rule at a massive scale over and over and over again.
You know, scientists have a name for this phenomenon. They call it emergence. It's the same idea that allows millions of simple water molecules to form a complex snowflake. Or think about traffic. Each driver is just following a few simple rules, like stop at red, but together they create these incredibly complex traffic patterns. That's how you get the magic from the math. The complexity isn't programmed in, it just emerges.
So let's try to bring this all together. What does this really mean for how we should look at this technology? Is it a ghost or is it a machine? So if you're going to take away one thing from all this, let it be this. These models are not conscious. They don't understand things. They are masters of pattern recognition, and their incredible skills are just an emergent property of applying a super simple rule at an unbelievable scale.
So in the end, it's not a ghost. It's a mirror, a very complex, statistically powered mirror. It doesn't have its own thoughts. It just reflects the patterns, the biases, the wisdom, and, the foolishness that it found in the trillion words we fed it. It's showing us the very structure of our own knowledge. And that kind of leaves us with a final, pretty provocative thought. If a machine can mimic creativity, logic, and even philosophy just by calculating probabilities, what does that say about us? It really forces us to ask what part of our own intelligence is just a very, very good prediction engine running on the hardware inside our skulls.